Oracle Database 23 AI Vector Search Specialist 2026. Stay with me. I will show simple steps to learn vector search for exams. You can get my complete practice test link in the description, with a discount coupon for full practice questions. These questions come with full explanations, which will help you get your certification on the first try. Please leave suggestions in the comment section, so I can improve my videos for you. And please, do not forget to subscribe, so you get new lessons on time. Section 1. Fundamentals of Vector Search and Setup in Oracle Database 23i topic. I will explain what vector search means, using simple words you can follow easily. Vector search finds similar items by comparing numbers that describe each item. We store those numbers, then we search by comparing to find close matches quickly. You will learn how to prepare data and how to save vectors in the database. First, we prepare text, images, or signals, then we convert them into numeric vectors. This conversion gives each item a number list that represents its meaning or features. In Oracle Database 23i, the database can store these vectors in special columns and index them. You need a table with a vector column, plus normal columns for id and metadata. I will show how to keep vectors small, and still keep search results accurate for tests. We use simple tools to generate vectors, then we insert them into the table for searching. Good vectors help the search find right matches, even when words are different, but meaning is close. You should normalize and choose the right vector size to balance speed and accuracy. Next, we set up an index that supports vector search, so queries run very fast. An index helps the database skip much of the data and find likely matches quickly. Oracle uses techniques like trees and clusters to make searches scale with many records. We must choose index parameters that match our data size and query patterns for best results. After index creation, we run test queries, measure speed and result quality, and adjust parameters. We can tune index settings or change how we build vectors until results look correct. Remember to keep training data clean, because bad data makes vectors give wrong matches later. When you add new data, update the index or rebuild parts of it, depending on volume. Small updates may be incremental, and large updates may need a full index rebuild for speed. You should monitor query latency, throughput, and accuracy to ensure the system stays healthy. Use logs and simple dashboards so you can see how many queries run per minute. We will practice simple queries that return the top closest items, sorted by similarity score. A similarity score shows how close two vectors are. Higher means more similar usually. You can also add filters on normal columns to narrow search results by category or date. Combining vector similarity and traditional filters gives precise results for user needs and tests. Security matters, so only allow trusted users to run heavy vector queries on production data. Limit query resources and consider quotas to avoid accidental overload from many complex queries. Keep backups of vector data and store original items too, so you can rebuild vectors later. When building your lab, use a small dataset first, then scale up as you understand behavior. I will give examples of SQL statements and short configuration tips for your study notes. Practice each step, test outcomes, and write simple notes, so you remember core ideas for exam time. Now, we will move to practice questions that check your basic understanding of these concepts. Section 1 Questions, Answers, and Explanations. 1. If you store a vector in a table, what does that vector represent? The vector represents a numeric summary of an item, showing its key features and meaning. A vector converts text or image features into numbers, for comparison in searches. 2. Why do we create a special index for vector search in the database? The index speeds up nearest neighbor searches by narrowing candidates before full comparison. An index reduces data scanned, improving speed especially when many records exist. 3. What is a similarity score, and why does it matter in results? A similarity score shows closeness between vectors, and it ranks search results by relevance. Higher scores mean closer matches, which helps pick the most relevant items fast. 4. How should you prepare data before converting it to vectors for storage? Clean the input data, remove noise, and standardize formats before generating numeric vectors. Clean data yields better vectors, and better vectors give more accurate search results. 5. When should you rebuild a vector index instead of updating it incrementally? Rebuild when many records changed, and incremental updates would make queries slow or inconsistent. Large data changes often need a full rebuild to keep index performance and quality. 6. What is a filter, and how does it help with vector search queries? A filter limits results by normal columns, letting vector search focus on relevant subsets only. Combining filters and similarity gives precise outputs, reducing false positives and noise. 7. Why normalize vectors before storing or comparing them in searches? Normalization makes vector lengths comparable, preventing score bias from vector magnitude differences. Normal vectors let similarity focus on direction, not on absolute size differences between items. 8. How does small vector sizes affect speed and accuracy for searches? Smaller vectors run faster but may lose detail, so you must balance speed against result quality. Choose vector dimensions that capture needed features without making queries slow. 9. What is a practical way to test the quality of your vector search setup? Run sample queries, check top results manually, and measure latency and correctness for each query. Manual checks and timing help you detect bad vectors or wrong index settings quickly. 10. How can you protect a production database from heavy vector queries misuse? Set resource limits, require authentication, and monitor for unusual query spikes or patterns. Quotas and monitoring stop one user or script from hogging database compute and memory. 11. Why keep original data alongside vectors in backups and storage? Originals let you regenerate vectors later, in case vectors need improvements or format changes. Backups with originals let you rebuild vectors with better methods in the future safely. 12. What role does metadata play when returning vector search results? Metadata provides context like title or date, so users understand each returned item quickly. Metadata does not affect similarity, but it helps present meaningful results to users. 13. How do you combine vector similarity with business rules in queries? Apply filters for business rules, then run vector similarity within that filtered result set. This keeps results relevant to business needs while still using vector closeness effectively. 14. What is a common cause of poor search accuracy despite correct indexing? Poor or noisy training data often makes vectors misrepresent items and lower result quality. Better data cleaning and better vector methods usually fix accuracy issues quickly. 15. How often should you review index and query performance for a vector system? Review performance regularly, for example weekly, and after major data or usage changes. Frequent checks let you catch regressions early and keep the system fast and reliable. Section 2. Building Vectors and SQL Patterns for Oracle Database 23i use. We now build vectors from text, images, and structured data, step by step for you. Text becomes vectors by tokenizing, embedding words, and combining into a single vector representation. For images, we extract features with a model, then convert those features into numeric vectors for storage. For structured signals, we scale numeric features, then pack them into vectors with meaningful order. You must choose vector size based on data type and expected accuracy needs for your tasks. A larger vector can capture more detail, but it needs more storage and query compute. We will write SQL templates for inserting vectors, retrieving nearest neighbors, and filtering results quickly. Use plain insert statements with vector columns and include metadata columns for easy result display. When selecting nearest neighbors, use the appropriate Oracle syntax that calls the vector search index. Limit the result set and include similarity score to show the most relevant items first to users. You can include an order by similarity clause and a where filter on normal columns in SQL queries. Test queries on small subsets first, and then run on larger datasets after indexing and checking speed. Batch insert operations should use efficient commit patterns to avoid locking and transaction slowdowns. For frequent updates, consider partitioning data by date or type to make maintenance faster and cheaper. Use explain plans to inspect query behavior and learn where indexes help or where they do not. If a query scans too much data, change filters, or add more selective columns, and retest performance. Monitor disk, memory, and CPU usage during heavy queries to avoid surprises in production environments. Keep a small test cluster for experimenting with index parameters without affecting real users or data. When you prepare your exam notes, include example SQL snippets and simple steps to replicate tests. Practice rewriting queries for different filters and practice reading execution plans for improvements. Finally, make short lab exercises for yourself, run them, and write quick notes about results for review. Section 2 Questions, Answers, and Explanations. 1. How do you convert text into vectors for storage in the database? Tokenize the text, compute embeddings for tokens, then combine into a single numeric vector. Tokenization and embedding convert words to numbers, enabling vector comparisons in searches. 2. What is a good practice when inserting many vectors at once into a table? Use batch inserts with controlled commits to reduce locking and improve overall insert throughput. Batching lowers transaction overhead and helps the database handle large data loads smoothly. 3. Why inspect and explain plan for a vector search query before production use? The plan shows how queries run, and it reveals if indexes are used effectively or not. Seeing the plan lets you tune indexes and queries to avoid full table scans and slowness. 4. When should you partition vector data, and what benefit does it bring? Partition when data grows large or by date, and partitioning reduces maintenance and query costs. Partitioning narrows searched data ranges, speeding maintenance like rebuilds and segment scans. 5. How can you include similarity scores in SQL results to show relevance to users? Select the similarity value from the vector search function, and include it in the result set. Showing scores helps users judge result relevance and aids debugging of search quality. Now we go deeper into real exam-level concepts. I will explain everything in simple English, so you feel confident in the exam. Keep your notebook ready, and write short points while watching this lesson. You can get my complete practice test link in the description, with a discount coupon for full practice questions. These questions come with full explanations, which will help you get your certification on the first try. Please leave suggestions in the comment section, so I can improve my videos for you. And please, do not forget to subscribe, so you get new lessons on time. Section 3. Distance metrics and similarity calculation in Oracle Database 23i. Now we talk about distance metrics, which decide how similarity is calculated between vectors. A distance metric measures how far two vectors are, using a mathematical formula. If the distance is small, items are similar, and if large, they are different. Common metrics include cosine similarity, Euclidean distance, and inner product calculations. Cosine similarity checks angle between vectors, not their size, which helps with text data. Euclidean distance measures straight line distance, useful for numeric feature comparisons. Inner product focuses on projection strength, often used in embedding-based search systems. You must choose metric based on how your vectors were generated originally. If vectors are normalized, cosine similarity often works very well for semantic search tasks. If vectors represent physical measurements, Euclidean distance may be easier to understand. Wrong metric choice can reduce accuracy, even if vectors and index are correct. In Oracle Database 23i, metric selection happens during index creation or query configuration. Always confirm metric consistency between vector generation and database search configuration. When testing metrics, compare precision and recall values across sample queries carefully. Precision means how many returned results are actually correct for your query. Recall means how many correct results were found from all possible correct ones. Balance precision and recall based on business requirement and exam scenario questions. Sometimes high precision is required, even if recall becomes slightly lower. You can simulate different metrics in a lab, and record their average similarity scores. Track performance impact also, because some metrics cost more CPU time. Exams may ask which metric suits normalized embeddings or which suits raw feature data. Remember, small distance equals high similarity in distance-based metrics. For cosine similarity, higher value means stronger match between vectors. You must clearly understand score interpretation for each metric type. Practice reading query results, and explain why certain items rank higher than others. This understanding helps you answer scenario-based questions confidently. Section 3 Questions, Answers, and Explanations. 1. What does a distance metric calculate in vector search? It calculates how similar or different two vectors are, using a mathematical formula. The metric measures closeness, which decides ranking of results in search queries. 2. When are cosine similarity metrics usually preferred? Cosine similarity is preferred when vectors are normalized and represent text embeddings. It compares angles between vectors, ignoring magnitude differences effectively. 3. What happens if you choose the wrong metric for your vector type? Search accuracy decreases, and relevant items may not appear at top positions. Each metric matches specific vector properties, so mismatch harms result ranking quality. 4. What is precision in vector search evaluation? Precision measures how many returned results are actually correct for the query. High precision means most shown results are relevant to user intent. 5. Why should metric configuration match vector generation method? Because vector properties depend on generation method, and metric must align with them. Misalignment causes incorrect similarity calculations and misleading ranking outcomes. Section 4. Performance tuning and scaling vector search systems. Now we focus on performance tuning, so your system handles large-scale workloads smoothly. When data grows, query latency can increase if index and hardware are not optimized. Start by checking index parameters, such as tree depth and clustering configuration. Better clustering groups similar vectors, reducing comparisons during search execution. Memory allocation also affects performance, because vector indexes use memory heavily. Ensure sufficient memory for caching index structures and frequently accessed data blocks. CPU resources matter too, since similarity calculations require numeric computations. Parallel query settings can improve throughput when many users search simultaneously. However, too much parallelism may increase contention and reduce overall efficiency. Always test scaling gradually, instead of jumping directly to maximum load. Use monitoring tools to observe query response time under different workloads. Check disk I/O rates, because large datasets may trigger heavy read operations. If storage becomes bottleneck, consider faster disks or optimized storage configuration. Partition large tables by logical groups to reduce search space for many queries. Rebuild indexes during maintenance windows to maintain balanced index structures. Stale statistics can cause poor execution plans, so update database statistics regularly. Set query limits to avoid unbounded nearest neighbor requests from careless applications. For example, restrict top results to a reasonable number like 10 or 20. In exam questions, you may need to identify which tuning step fixes slow queries. Look for hints about memory pressure, CPU saturation, or missing index usage. Scaling also involves backup strategy, because vector data volumes can be large. Plan incremental backups, and test restore procedures to ensure data safety. A well-tuned system provides stable latency, even when dataset size increases significantly. Keep documentation of changes, so you understand what improved or harmed performance. Train, test, measure, adjust, repeat. This cycle helps you improve system behavior over time. Section 4 Questions, Answers, and Explanations. 1. Why does clustering similar vectors improve search performance? Clustering reduces number of comparisons, because similar vectors are stored close together. When grouped, search can skip unrelated regions and respond faster. 2. How can insufficient memory affect vector index performance? It causes frequent disk access, slowing down similarity calculations significantly. Cached index structures in memory allow faster comparisons than disk reads. 3. Why should you limit the number of nearest neighbor results returned? Limiting results prevents heavy computation and reduces unnecessary system load. Smaller results sets lower CPU usage and keep latency stable. 4. What role do database statistics play in vector query optimization? Statistics guide the optimizer to choose efficient execution plans for queries. Outdated statistics may cause full scans instead of using vector indexes. 5. What is a safe approach to scaling vector search workloads? Increase load gradually, monitor metrics carefully, and adjust configuration step by step. Gradual scaling reveals bottlenecks early, preventing sudden system instability. Now we complete your preparation journey. Stay focused with me, because these sections help you answer advanced exam questions. I will keep everything simple, clear, and practical for your learning. You can get my complete practice test link in the description, with a discount coupon for full practice questions. These questions come with full explanations, which will help you get your certification on the first try. Please leave suggestions in the comment section, so I can improve my videos for you. And please, do not forget to subscribe, so you get new lessons on time. Section 5, Security, Governance, and Lifecycle Management for Vector Systems. Now we talk about security, because vector data may contain sensitive business information. You must control who can insert, update, delete, or query vector columns. Use role-based access control, so only authorized users run heavy similarity searches. Grant least privilege access, so users only see data needed for their tasks. Audit vector queries, especially those returning large result sets or scanning many partitions. Logging helps you detect misuse, abnormal patterns, or suspicious access attempts early. Encrypt data at rest, and also encrypt connections between clients and database servers. If vectors represent customer content, apply data masking for non-production environments. Governance means defining rules for data quality, retention, and version management. You should document how vectors are generated, including model version and pre-processing steps. When models change, you may need to regenerate vectors for consistency and fairness. Keep version tags in metadata, so you know which model produced each vector. Lifecycle management includes ingestion, indexing, monitoring, archiving, and safe deletion. Old vectors that are no longer needed should be archived or removed carefully. Before deletion, verify backup availability and confirm compliance requirements are satisfied. Exams may ask about risk mitigation steps for large-scale vector deployments. Answer with access control, encryption, monitoring, and documented operational processes. Always separate development, test, and production environments for safety and stability. Test new index parameters in staging before applying them to live systems. Set policies for re-indexing frequency based on update volume and performance metrics. Good governance reduces errors, protects data, and supports long-term reliability. When auditors review your system, clear documentation builds trust and clarity. Security is not one step, it is continuous monitoring and improvement. Review permissions regularly, and remove unused accounts or expired credentials. These practices make your system strong, safe, and exam-ready. Section 5 Questions, Answers, and Explanations. 1. Why should vector columns have restricted access permissions? Because vectors may represent sensitive content, and unauthorized access can expose private data. Role-based access control ensures only approved users run searches or modify vector data. 2. What is the purpose of tagging vectors with model version metadata? It helps track which model generated the vector, supporting audits and future updates. Version tags allow safe regeneration when models change or improve later. 3. Why separate development and production environments for vector search? Separation prevents experimental changes from affecting live users and real data. Testing in staging ensures stability before applying configuration changes to production. 4. What is lifecycle management in vector systems? It includes ingestion, indexing, monitoring, archiving, and safe deletion of vector data. Managing full lifecycle keeps data organized, secure, and aligned with policies. 5. How does encryption protect vector search systems? Encryption secures stored data and network traffic from unauthorized interception. Data at rest and in-transit protection reduces risk of breaches. Section 6. Advanced Use Cases and Real-World Design Scenarios. Now we explore advanced use cases, which often appear in scenario-based exam questions. One use case is semantic document search, where meaning matters more than exact words. Another case is product recommendation, based on similarity between user behavior vectors. Fraud detection can use vector similarity to find patterns similar to known fraud cases. Image search systems compare feature vectors to find visually similar images quickly. You may combine vector search with traditional SQL joins for hybrid applications. For example, find similar products, then filter by price range or availability status. Design decisions depend on data size, query frequency, and response time expectations. For high-traffic systems, caching frequent query results can reduce repeated computations. Batch processing can prepare vectors offline, reducing pressure on real-time workloads. Real-time systems require low-latency indexing and near-instant availability of new vectors. You must balance freshness and performance when choosing update strategies. In exam scenarios, look for clues about workload type and pick proper design solution. If data changes rarely, heavy indexing with periodic rebuilds may be acceptable. If updates are frequent, choose incremental indexing and partition-friendly design. Monitoring real user queries helps refine vector generation and similarity thresholds. Sometimes threshold-based filtering improves quality by excluding very low similarity results. Hybrid ranking may combine similarity score and business score for final ordering. For example, similarity plus popularity score may give better user experience. When explaining architecture in exams, mention scalability, monitoring, and governance clearly. Show understanding of trade-offs, not only features, because design is about balance. Train, test, evaluate, improve, repeat. This simple cycle helps refine real-world vector search systems. Section 6 Questions, Answers, and Explanations. 1. How can vector search support semantic document retrieval? It compares document meaning vectors, returning texts with similar intent, not exact words. Semantic vectors capture context, enabling retrieval beyond simple keyword matching. 2. Why combine vector similarity with traditional SQL filters? Combining both narrows results to relevant items within business constraints. Hybrid queries provide precise, practical results for users. 3. What is a key challenge in real-time vector indexing systems? Maintaining low latency while handling frequent updates and new vector insertions. Real-time systems must balance freshness with stable performance. 4. How can threshold filtering improve search result quality? It removes items with very low similarity scores before presenting results. Thresholds reduce noise and improve perceived relevance. 5. Why mention trade-offs in exam design scenario answers? Because good architecture decisions balance performance, cost, accuracy, and maintainability. Showing awareness of trade-offs demonstrates deeper understanding of system design. We have now completed all major sections for your certification preparation. Revise each section slowly, and practice writing short explanations in your own words. Check the description to get the full course and complete practice test bundle. Use the discount coupon, and prepare smartly for your certification attempt. Please share your feedback in comments, and do not forget to subscribe for more lessons.